What's up, guys? It's CS here, and I just want to have a quick look and chat about DeepSeek again. Some people have asked me, how exactly did DeepSeek outperform the competition with the so-called lesser GPUs? If you guys look at one of my other videos that talked about that. But talked about some of the optimizations that they use. And again, this is just playing the game that Nvidia has set up here. And maybe it actually says more about Nvidia. So traditionally, most of the training and all the inference is done via Nvidia's CUDA framework, right? In TensorFlow, PyTorch, those kind of frameworks. And so the way that is normally done is, like I said, through the CUDA interface. And there is something different called Nvidia's PTX. And if you look at it, basically, my explanation, I also see some other outfits here describe it the same way. Now, if you look at some examples of how you implement it, it looks eerily similar to assembly language. So as you guys know, assembly language, or if you might know, it's a lower level language than a typical compiled higher level language. So an example of like maybe a higher level language might be like C++ or Python or whatever, something like that, okay, like Java. Assembly language is another level down, so as a result it is much more efficient. So as well, looking in the white paper, this is another thing that they had to do. Obviously though, if everyone could do it, that's the whole reason for APIs and you know, like higher level software programming, right? It's a lot easier to implement, but obviously it's not as efficient, as fast as assembly. So the Nvidia's PTX allowed them to make a lot of these efficiencies here. So if anyone's wondering, aside from whatever other optimizations that we talked about here, I think this is one of the keys to doing that. Also, it makes us question then, do we really have an optimized framework for using our GPUs in artificial intelligence? I think the answer is that we can still have a way to go. I'm going to throw it out here as well, that could we be having a bit of a market monopoly here, where a company like Nvidia realize that if they don't optimize as much, or they don't put enough money into it, you can still sell more GPUs, right? So essentially, you can do a lot more with a lot less, as we can see here. In fact, about 2,000 GPUs was enough to train DeepSeek, and I think a direct corresponding relationship here is just really the what they call it is to be about 10 times higher efficiency. So otherwise, it would need you know, way more, right? We're talking, instead of 2,000 GPUs, you need 20,000, and so that again, that's a direct result of using Nvidia's assembly language, or PTX as they call it. So this kind of leads to the question that as we see more and more optimizations, can we in fact not even have to upgrade our GPUs to a certain extent? I think clearly that this proves that the GPUs that we already have that are being used for AI, they're largely being hindered just by, you know, maybe inefficient programming. And again, we can look at maybe more threads as well. I did another video about that. But with more threads, you can see again that the specs aren't that bad. They should be somewhat comparable to some of the Nvidia GPUs for gaming, and they're not. Why? Obviously I don't think more threads is intentionally doing this, but they're new to the game. It takes a long time and a lot of work to make things more efficient and compatible, right? And as we can see again, even AMD or their predecessor ATI, they struggled for a very, very long time to get that right. So as we can see here, maybe a lot of the innovations at this point are going to be coming in, you know, into the approach, in the software design and implementation of this hardware. It looks like that's the key story of 2025, guys. Anyway, that's my take on it, guys. What do you think? Okay, thanks, guys. Please like, share, and subscribe, and I'll see you guys next time.